In this section of the video, we'll be covering the motor of the hoverboard FMEA analysis. Starting off with a little bit of background on the motor and its components. Hoverboards are propelled by electric motors that are housed within each wheel. This motor works in conjunction with a gyroscope and speed control printed circuit board that you can see in this image down here. So the circuit board is getting the signal and sending that signal to the motor and the current to allow it to move, and the motor is receiving the feedback from the gyroscope sensor. Now, just a little basic background on the electric motor and how it operates. Power is provided to the motor by the battery bank, as analyzed earlier, and the electric motor utilizes brushes and rotors to create an electromagnetic field, which is the current passes through the brushes, causing the main armature or coil to rotate, and that rotation allows for the armature to spin, which propels the hoverboard, and it will move either forward or backward based on the gyroscope sensor information received by user input. So the function that I'll be analyzing of the motor is its basic function to propel the hoverboard. The basic requirement is that the hoverboard must move forward or backward based on the gyro sensor information. The first potential failure mode of the motor is a disconnected or unwired terminal, as shown in the photo below. The main effect of this failure is that if the wires are disconnected, there will be no power to the motor. So that being the case, this would be the case of highest severity for a failure mode. And potential causes of the failure could be bad terminal contacts, broken wires, corroded contacts, or otherwise loosened or damaged. And this is obviously going to cause no power to the motor, and the user won't be able to use the hoverboard. The next potential failure mode would be the damaged motor housing, as shown. This would cause damage to the internal rotor stator potentially, which could result from overuse or abuse, actual material fatigues and cracking, or other physical damage. Next potential failure mode would be a damaged or broken rotor. This would cause no power transmission and potential damage to the bearings. This would be the next severe case of failure, and this could be influenced by thermal stresses, corrosion, damage, or an imbalanced rotor. And finally, a damaged or broken stator could be a failure mode, causing power loss and reduced motor efficiency. Potential causes of this failure are broken windings, high operating temperatures, rewind failure for rewinding the actual armatures, and potentially corrosion.